In question number 7, the space between two large plane surfaces is filled with oil. Separation between plane surfaces is h. Force required to drag a thin plate of area A at x equal to h by 2 as shown with constant velocity v0 is f. The plate is parallel to the plane surfaces. Choose the correct options. So, if I apply the formula that f is equal to eta A dv by dz, then I can write this f is equal to eta into, since this cross-sectional area is at a distance h by 2 and the upward cross-sectional area is also distance h by 2. So the velocity of the liquid at this point is 0 and at this point is also 0. So I can write this eta times A into V0 upon h by 2, because at x equal to h by 2 the force F is acting and the plate is moving with velocity V0, plus A into V0 divided by h by 2. So from here the value of eta comes out to be hf divided by 4a V0. So option A is correct and B is wrong. Let's check the validity of option C and D. So if the plate is at x equal to h by 4, then the f dash required in order to move the plate with constant speed V0, it can be written as eta times A into V0 divided by h by 4 plus A into V0 divided by 3h by 4. So if I substitute the value of eta, then the value of this expression comes out to be 4 by 3 into f. If I substitute x is equal to 3h by 4, then also this equation will come up. So the answer will remain same. So option C and D are also correct. So the correct answer for question number 7 are option A, C and D. Let's move to question number 8. In question number 8, a rectangular vessel with a small hole in its bottom is fastened to a cart. The total mass of the vessel and the cart is m and the base area of the vessel is A. Horizontal force F has to be applied so that maximum amount of water remains in the vessel. For this given condition, choose the correct options. Rho is the density of water. So as per given question, for maximum amount of water in the vessel, the surface of the water in the vessel would be like this. So at that moment, if this is the surface, then the net acceleration, then G effective will act perpendicular to this surface. So let this angle is theta. So at that moment, we can say that tan theta is equal to perpendicular surface is C by 2 divided by C. So it comes out to be 1 by 2. Also, if the vessel is moving with acceleration A, so if I consider a small segment, a small element on this surface, then with respect to the vessel, if I apply the pseudo force, then MA will act in this direction. This is the small element whose mass is let M, and on this element mg is acting in this direction. Then this angle is also theta. So if I take the component of this force in this direction, that will be ma into cos theta, and the component of mg in this direction will be mg into sin theta on the considered element of mass m. So from here, this force must cancel each other. So the component of forces tangential to the surface must balance each other, because the net force must act perpendicular to the surface on the considered element. So from here we can see that tan theta is equal to A by G. So this is equal to A by G, and the value of A comes out to be G by 2. So option A is correct and B is wrong. Now we have to also find out the horizontal force F. So the horizontal force F is equal to total mass into acceleration. So total mass can be written as capital M plus the mass of this water can be written as half into base, that is C, into height, that is C by 2, into inside length is A by L, so that is the volume, into density, so this is the total mass of the system, and multiplied by the acceleration, so that is G by 2. So if I solve this, then option C is also correct. So the correct answer for question number 8 are option A and C. Let's move to question number 9. In question number 9, a cavity of radius r by 2 is made in a uniform sphere of mass m and radius r as shown in the figure. A particle is projected from the center of cavity at an angle of 45 degree with a speed under root gm by 4r in xy plane. Considering the motion of particle before collision with the wall of cavity, choose the correct options. So first of all, if I calculate the gravitational field inside the cavity, then it can be find out E vector is equal to Gm by r cube into small r vector. So that can be written as the separation between this center and this center. So that is r by 2, and the direction is along negative x direction. So into minus I cap. So this comes out to be Gm by 2r square into minus I cap, and it is uniform. So if I check the options, field inside the cavity is uniform, so option A is correct. Path of the particle will be parabolic. Since the gravitational force on the particle will act in this direction always, so the path of the particle will be parabolic because the angle between velocity vector and the acceleration vector is obtuse. So option B is also correct. Time after which velocity of particle becomes parallel to y-axis is this much. So let's calculate. It means that the horizontal component of the velocity of the particle must be 0. So I can write Vx is equal to ux plus ax into t. So 0 is equal to ux is v cos 45 degree. So the value of v is under root gm by 4r into cos 45 degree, that is 1 by root 2, plus acceleration in negative x direction is gm by r square. So with sign convention I am writing minus gm by 2r square into t. So if I solve this, the value of t comes out to be under root r cube divided by 2gm. And at this moment, the velocity of particle, so option C is also correct. In option D, velocity of particle in y direction will not change. So this option is also correct because the gravitational force on the particle act in the negative x direction and it does not impact the y direction motion of particle. So option D is also correct. So the correct answer for question number 9 are option A, B, C and D. Let's move to question number 10. In question number 10, a particle suspended by a thread is projected if V0 is equal to under root 3gl from the lowest position as shown in figure. The string becomes slack when the string makes an angle theta with the vertical. Then we have to find out the value of theta and the minimum speed of the particle during motion. So at this moment the speed is v. So if this angle is theta, then this angle is also theta. So at this moment, if I write the equation, then t plus mg cos theta must be equal to m into v square by L. So it is given in the question, at this position the tension becomes slack, so that value of tension becomes 0. So from this equation we get the value of v square, that comes out to be gl into cos theta. If I apply the principle of conservation of mechanical energy at this position and at this position, then I can write half m v0 square. So this is my reference frame of gravitational zero potential energy, is equal to half mv square plus mg, and this separation is L into 1 plus cos theta. So from these two equations, if I find out the value of cos theta, then it comes out to be 1 by 3, or theta is equal to cos inverse 1 by 3. So option A is correct and B is wrong. Now I have to find out the minimum speed of the particle during its motion. So after this moment, the particle will follow the parabolic path and its speed is minimum, and when the particle is at the topmost position of its motion. So this velocity is v into, this angle is also theta, so v into cos theta. So vx is equal to v, that is under root gl cos theta. So this comes out to be under root gl by 3 into cos theta, so that is 1 by 3. So option D is also correct. So the correct answer for question number 10 are option A and D. Let's move to question number 11.